We're going to do what we can to graph these things here in whatever way makes the most sense. First of all, we need roots and vertices for all of them. The roots are easy to find if we factor them. It's x plus 4 and x minus 2, because 4 times negative 2 is negative 8, but 4 minus 2 is still going to be 2. If we set that equal to 0, we'll find our root. So one root's a positive 2. If I set that equal to 0, I add the 2. And if I subtract the 4, that's another root. Might just be easiest for us to do that. 1, 2, 3, 4, and positive 2. Well, right in between those two things is our vertex, directly in the middle. So if I add those two things together, I get a negative 2, but divide by 2 to find the midpoint. Negative 2 over 2 is equal to negative 1. That's actually the midpoint of our vertex, right there. And so what thing we can do is we can plug that negative into either this equation or that equation, and it'll give us the y value of our vertex. Or we can do some stair steps or whatever, but let's just plug it in. If I plug it in here, I end up with a negative 1 plus 4, that's 3. A negative 1 minus 2, that's negative 3. If I multiply that together, it gives me a negative 9. And that's basically my vertex. Negative 1, negative 9 is the vertex. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, a stair-step approach with a coefficient of 1 out in front means the first step is going to be 1 up and 1 over. The next step is going to be the next odd number, 1, 2, 3, and over. Up, 1, 2, 3, and over. The next step should be up 5, 1, 2, 3, 4, 5, and over. And so that pans out exactly as we had expected. That's one way of finding all those values. You can count them up, or you can look at this. For one thing, that's your y-intercept, right? Negative 8 is in fact your y-intercept, so if you say 0 and 1 and negative 2 and negative 3, there's 8, negative 8, and according to symmetry this should also be a negative 8. Then if I plug 1 in back like we did before, we plugged in negative 1. 1 plus 4 is 5, and 1 minus 2 is negative 1. Okay, so 5 times negative 1 is a negative 5. So you can plug stuff in, or you can map it out on your board like that. The difference with this one here, if you remember h and k plus 0, right? Your vertex is at negative 3, or I'm sorry, it's positive 3 comma 0. Change the sign of what's inside, keep the sign that's outside. Your root is still at 3, 0 because it's going to be at the same spot, 1, 2, 3. Okay? That negative tells me this thing has an upside down orientation, so that stair step we did over here is just going to be down 1 over 1, and then down 1, 2, 3, and over 1. Same thing's going to apply in this direction. And so 3, 0 is our vertex. Go to 4 and 5, go to 2 and 1. 1 below is the first step, and then down 1, 2, 3 is the second step. So I did more with the stair step approach here and more with the plug-in approach here. Let's do kind of at least one more here. I can take out a 2x, left with an x plus 2. So that's going to give me a root at 0 if I set this equal to 0. 0 based on setting 2x equal to 0. X is going to be 0 for that one. And set this equal to 0. That's going to be a negative 2. So 0, 0, and negative 2, 0 are my two solutions. This thing is upright, but it's also stretched. So I know that the vertex is going to be right in between those. So if I plug in a negative 1 into either form of the equation, I find it easier to plug into the factored form. Negative 1 here makes that a negative 2. Negative 1 here makes that a positive 1. And 1 times negative 2 is a negative 2. So it's going to go down 2, and that's consistent with our stair-step approach, especially when there's a coefficient out in front of here. So I got a negative 1, negative 2. The first step is going to be a 0 on either side. So 0, 0, and negative 2, 0 are those two solutions. And my next step would be a step up 3, but in this case here it's a 3 times 2. So it would be up 6. But aside from whether you understand that or not, if you plug in a 1 or a negative 3, you'll get that same answer. Plug in a 1 here, you get a 2. Plug in a 1 here, you get a 3. 2 times 3 equals 6. And so over 1 up 1, 2, 3, 4, 5, 6, and 6. There's our stretched version of our parabola, and that's a negative 2. The last one here, if I get you started, you take out a 4, you're left with an x squared minus 1. That factors to be x plus 1 and x minus 1. That's where your roots are going to be. Okay, your vertex is going to be in between those. And in fact, your vertex, your y-intercept is at negative 4, 1, 2, 3, 4. And so you've got this very steep thing going on here. Your vertex is at 0, negative 4. And at 1 and negative 1, you've got a 0 in each case. So all we really have to do is plug in either a 2 or a negative 2 into either the original equation or the altered equation. The altered one here, 2 squared is 4, and 4 minus 1 is 3, and 3 times 4 is 12. If I plugged it in here, 2 squared is 4, times 4 is 16, minus 4 is equal to 12. You get 12 either way. It's off the chart, and that's about it.